Just to give you guys a little background, this is Mike Smid with TEC, and on the phone and on the giving a presentation is going to be Tony Palmatier with the Airflow Equipment Company. And basically, just to give you a quick background of Airflow and TEC, we basically entered into a partnership a little over a year ago, right, Tony?
Yeah, about a year ago.
And we've had a lot of success with the product in the past year, and we wanted to kind of do a little webinar for some of the folks on the line, and just for everybody to kind of see the quality of the product that Airflow puts out to the marketplace. So I'm gonna let Tony kind of steer the presentation from here on out. And if anybody has any questions, what we'll do is I'll kind of monitor the questions, Tony. And if any questions come through, I'll stop you, and then we'll present the questions, and you could answer them. Okay?
Yeah. Yep. No problem.
All right.
Okay. Thanks, everyone. As Mike said, my name's Tony Palmatier from Airflow Equipment, and just to give you, we'll just kind of go over a presentation here to give you an idea of the product we build and get a general idea for the product and what we do. As it shows there on the screen, we really make custom air handling units. We're based out of Kalamazoo, Michigan. So I guess one of the neat things is, if we were to do a project together in the future, we're relatively close, being maybe 2 to 3 hours away from the Chicago area, depending upon what side of Chicago you're coming from. So we are pretty close, and that can be advantageous. Moving on to just kind of a brief background and brief history. I guess first I'll point out on this first screen you see just a picture of our building here in Kalamazoo. And we are in a 80,000 square foot manufacturing facility, that's roughly about 7 years old, was a brand new facility. Actually was built, I'm going to say, 7 to 8 years ago. It was 60,000 square feet. And then about a year and a half later was expanded to 80,000 square feet. That's the current facility that we have. Just a quick background. Company was founded back in 1985 by Dick DeYoung. So we've been doing this for about 27 years now. He originally got into it prior to that, was working as a manufacturer sales rep, selling several HVAC-related products, including he was repping Tempmaster Corporation, some of their products, and carried a fan line and a coil line. We were lucky enough here in Kalamazoo to be located right next to what was the old Upjohn Corporation, which is now Pfizer, the pharmaceutical company. And then also at the time, Dick's father had owned a sheet metal shop in Kalamazoo. And through selling Tempmaster products and fans and coils to the Upjohn company, had developed a rapport with many of the engineering staff and engineering folks at Upjohn's. And you know how those relationships happen, as he was providing some equipment to them. That was right about at the time where the USDA was really starting to dictate to the pharmaceutical companies what they needed to do as far as what type of ventilation they needed and what type of equipment they needed. And at that time it became evident to the folks at Upjohn that the air handling units that they were buying were not meeting the requirements that was being laid out, and they needed to look to a different alternative to find the equipment that they needed. So seeing an opportunity, Dick made a proposal to some of his engineering folks at Upjohn to let him build an air handler for him. And so that opportunity came about. He was able to bid a project. He was already carrying the coils and the fans. His father owned a sheet metal shop. He was able to build a unit in that sheet metal shop. Project came up. He bid it, got the job, was able to build the first unit. That was very successful, and as they say, kind of the rest is history. So that's kind of the humble beginnings of the company, and that's just to illustrate that definitely in the beginning, back in the early 80s, the company was really focused on building a high-quality pharmaceutical-grade air handling unit. something that could be washed out, something that would have wash down purposes for the pharmaceutical grade, something that had really looked for something that was maintainable, that could be cleaned, that the maintenance staff could get into, that had good access, that they could work and repair as necessary, and that's kind of the beginnings of the company.
And one of the key things, Tony, and then one of the is the Airflow is obviously made in Kalamazoo, Michigan, so it is a U.S. company, and from a competition standpoint, most of the competitors in the custom market are either making their products in Canada, so it's always nice to, obviously, when we do this, to have a custom line that's made right here in the United States. And the other great thing is that, I mean, we've done some projects over the last year. If something does come up, small or big, Tony can have a guy come into town here immediately. He doesn't have to arrange a plane flight and wait days and days to get a response from a big company. They react kind of like what I feel how TEC reacts in the marketplace, which we react to the end user immediately. So that's one of the true selling points that I think with Airflow itself also.
Yes, indeed. It's definitely nice being close. Like I said, just being a couple hours away. If something should occur, we are able to dispatch a technician to be down. If not the same day, probably the next day, and get that initial information done and start getting things taken care of. So, I guess moving on to the next slide, just to give you a feel for the company and what the market is. Obviously, the pharmaceutical grade type air handler is where we started. But if you take a look at this list, which is just a very, very partial list, it'll give you a flavor for kind of the markets that we target. Pfizer, the Upjohn company, still do work with them, but looking at like Bronson Hospital, Theta Clark Medical Center, Munson Medical Center, Marshfield Clinic, Mercy Medical Center. These are obviously all hospitals or clinics, and so that's very much one of our large markets. And also you see University of Michigan, University of Illinois, Michigan State. We could go on, but Iowa State, hospitals, universities probably makes up about 80%, 85% of our business and where we do. Where we're selling our product, and then as some of the other things you see here being more industrial, things like Ford Motor Company, Lockheed Martin, work with the state of Michigan, Consolidated Paper in the past. So really focusing on that pharmaceutical, hospital, industrial type products. Again, places where people are looking for a high quality piece of equipment that's going to last, that has good access to be maintained, and the maintenance people are going to be able to work on and be happy working on. That's really what our market is, and obviously along with that is the high quality construction, being able to take high pressures with very low leakage. I'm just going to move on and start right into construction and how we build the units. Kind of starting from the base up and going through the casing, talking a little bit about the components we use. Our base construction is relatively straightforward. We use all structural steel in our bases. A 6-inch, 8.2 pound C-channel is our standard material. Of course, depending upon the situations, we can use whatever you need, anything through a 4-inch base all the way up to a 12-inch base, using C-channel to whatever the unit needs. You can see the pictures there. Just kind of show the units being laid out. We lay them out. Everything is solid welded. Lifting lugs are put on. Up in that, you can see in the upper picture there, the subfloor being welded on, and we go ahead. You can see in that picture all that subflooring is cross broke. So when you put the insulation in, it holds that insulation up against the flooring. Make sure there's going to be no gaps where any condensation can form. And also that helps obviously eliminate any vibration potentially in the unit. You're not going to get any rattling or anything from that subfloor. All our bases then are filled. Here's just more examples of the bases being laid out. All the bases at this point are filled with fiberglass insulation. We put 2 layers of 3-inch, so a total of 6 inches of fiberglass insulation to give an effective R value of 22 in the base. As far as the flooring goes, our standard at the time is 1/8 inch aluminum tread plate flooring, but we will do different types of flooring depending upon the situation. You can see in these slides, the lower left corner, you can see the aluminum tread plate, and right above that is a mild steel tread plate. One thing to point out in these pictures, as you can see in those 2 pictures that I pointed out, you're going to see the V-slope in the flooring. That's one of the things that we do that we think is kind of unique, kind of unique in the industry. In any area where you might anticipate water or condensation in the unit, we will go ahead and form these V-slopes in the flooring, slope it to a 1.5 inch drain, which then exits through the base rail, and you've basically got a wash-down construction. We can do that at anywhere in the unit. Basically, we can do every section that way. Or depending upon the unit, we can pick and choose. Obvious areas for that are, downstream of a chilled water coil, an outside air intake section, things of that nature. So anywhere you have the potential for water, you're going to have a way to manage that and to drain it out of the unit, and or for 100% washdown construction. Other options are obviously available. The aluminum tread plate seems to be quite popular these days, but also the mild steel. We will gladly do stainless steel flooring, tread plate, or stainless steel sheet. I've even done some just aluminum sheet units before. So pretty much whatever you need is available depending upon the situation, whether it's performance or cost. Galvanized flooring obviously is an option as well. So whatever the situation is, we can tailor the construction to that approach. That's kind of the basics on the flooring. We'll go ahead then and move right into, once that base assembly is fabricated, everything is welded up solid, then we're going to talk about the casings a little bit. Our standard casing is going to be a 4-inch thick tongue and grooved panel that we build here in our plant, which then is built up into the casing system for the unit. We use 4 inches, and our standard insulation material is 4 inches of rigid mineral wool insulation. And we use that for a variety of reasons that I'm going to talk about right now. We do know that, fiberglass is out there. Foam is becoming more prevalent in the industry. But the rigid mineral wool is something that we continue to use. We believe it has advantages for a couple things. First and foremost is the sound attenuation. That rigid mineral wool with the mineral fibers is outstanding at getting rid of sound. Really, if you're going to do a unit, sound is a concern. The mineral wool is going to be the best material for that. We will obviously build solid inner and outer, and I'm skipping a little bit on the slide, but we can couple that with our perforated inner acoustical liners. Then when you have the perforated material, 4 pounds or 4 inches of the rigid mineral wool, you will get outstanding sound attenuation that's really second to none. Foam is not going to give you the sound attenuation of mineral wool, and neither really is fiberglass. So that's one of the things that we really take a lot of pride in, is building a unit that's going to be quiet, that does a great job of killing the sound before it leaves the unit, and not pumping all that sound down the ductwork. Going back to a little bit of the focus on sound for a minute, one of the things that we can do is being a custom manufacturer is if we're building a unit and you come to us and say, hey, this is a unit, sound is particularly important, we've been able to do a lot of different things. We've filled the base cavity with mineral wool insulation to act as a sound attenuator for that radiated noise down through the bottom of the unit, or we've actually went to the extent of placing 3/4 inch sheetrock inside the base and then filling it with mineral wool and a layer of fiberglass to really act as kind of the Cadillac, if you will, for sound attenuation through the base of the unit. I have one example where we did that. We put a 30,000 CFM rooftop unit with a service corridor over a operating room up at Munson Medical Center in Traverse City, Michigan. As we went through the development of that unit, obviously it was repeated again and again that sound was critical on this unit. Radiated noise through the base was very critical. Is you're above an operating room and you've got surgeons down in that operating room and they like things to be quiet. And I think we all know they have a lot of pull in the hospital, so there was an awful lot of concern. We did put the sheetrock in the base, the mineral wool, topped it with fiberglass insulation, using the mineral wool throughout the panels, and that unit has been successfully running for about 3 years now with no complaints on noise. So if sound is critical, we certainly have a solution and can offer something that's maybe a little bit different than what most manufacturers may come up with.
And one of the other benefits, Tony, is mineral wool is if for some reason it does get wet, let's say insulation gets wet or foam gets wet, what happens in that case?
Well, yes, exactly. The rigid mineral wool, first off, if it does get wet, it does not wick moisture. It's not like fiberglass where once you get a corner wet, it's going to suck it up through all the insulation and destroy it. It does not wick moisture, and it does not lose its R value. It does not collapse on itself because it's rigid, so it will maintain its structure. It maintains its R value, and it will continue to give you that R value you need even when it's wet. It will dry out and maintain the same R value over time. So that's a couple of the reasons why we like to use it. Superior sound attenuation. It has the ability to resist moisture. And one of the other things that we really like about it is just the stability over time, as I talked about. Even if it gets wet, it doesn't shrink. It's 100% dimensionally stable. It doesn't wick moisture. We know that if we put that in there, we know the R value over time, 5 or 10 years down the road, is going to be the same thing that it is today. And so we've been using that and have had very, very good luck with it and been very successful. Moving on a little bit more to the just general panel construction, we can offer pretty much all the varieties. Like I said, we build our panels here in our shop. So galvanized, obviously inner and outers, 16 gauge, 18 gauge, 20 gauge, whatever the case may be. Certainly can do stainless panels, whether it's all stainless, whether it's a stainless inner and a galvanized outer. We can and will do that. We can do aluminum, same thing, aluminum inner and outer, aluminum inner. For example, some specifications will have a perforated aluminum inner with a galvanized outer. We can do that without issues. One of the neat things for wash down that I've seen, obviously in like a food grade type unit, is a stainless. We'll do a stainless inner, and we can do a galvanized outer, but then we can do the flooring out of stainless. Every section sloped to the drain through the base rail, like I spoke about. So now you've got a true wash-down unit with stainless steel interior, all the walls, all the floor sloped. You 100% drainage of water out of that unit. So that's something that we do on a regular basis. Again, talking just real briefly about the perforated inner liner. We'll do the perforated inner liners wherever it makes sense to protect that sound path out of the unit, whether it's downstream of the fan and the discharge or upstream of a return fan as that sound path is going down into the building. We can go ahead and do the perforated liner to kill sound as needed. A couple other things to point out. Thermal break is definitely an option, and maybe you're asking yourself, why is it an option? Well, what we found through the years is using the 4-inch casings with 4 inches of mineral wool. If you have standard discharge temperatures, that are 54, 55 degrees, really at that point a thermal break is not really even needed to avoid condensation when you start getting down into the real low discharges, 52, 51, 50. Then a thermal break is definitely a good idea, and we will build a no-through metal panel base so you can get that true thermal break option. One of the things we do now is we hem the outer edge of the panel for a very clean appearance, and that also makes the unit, helps to add to the tightness of the unit. You can see the next line talks about 0.5% leakage at 10 inches of static pressure. That's something that we test to on a regular basis, day in, day out, and we can hit that with our normal unit construction. So again, if you're looking for that tight specification, 0.5% leakage for a hospital or university, that's really where we excel, and that's the quality of unit that we build. We will do pressure testing here in our factory. If we were to build a unit for you, you wanted to come witness that testing, you're more than welcome to. We do have our own pressure blower, and we will test it, right in front of you, and you can verify the performance. And then roof options, we'll either do a membrane roof or a standing seam roof, depending upon what the customer wants and what the specifications call for. Moving on, we'll go through and talk about some of the main components in a unit. Excuse me. Talking about fans, we typically use Twin City fans or Green Heck is our standard fan manufacturer. We use a lot of blue fans from Twin City. As you see in this slide here, we definitely get into using multiple fans into a fan array. 2, 4, 6 fans is generally what we'll build as far as a fan array. We'll take the regular plenum fans, build them in an array, mount the upper fans all on 4x2 by 1/4 inch structural tubing for a very rigid mounting system. And we can do that with plenum fans, with double width, double inlet fans, whatever the situation calls for. All different types of bases. We are going to mount our fans on a solid welded structural steel base. In fact, the same 6-inch, 8.2 pound C-channel that we're going to use for the base structure is what we use to fabricate fan bases. All the options are in play. Concrete inertia base is available. We can pour the concrete here in the factory, or of course, be field the concrete be field installed. Either option's available. We also make what we like to call an anti-flex base, which is a fan base fabricated from 8-inch by 4-inch by 1/4 inch wall tubing that has been offered and used as basically an alternative to a concrete inertia base. The 4-inch by 8-inch by 1/4 inch tube is obviously very stiff, has quite a bit of mass. We found in many cases that to be as stiff or stiffer than a concrete inertia base. So if there is a situation where you need a very tight vibration spec, but don't want the weight of the concrete, we can do that 8-inch by 4-inch by 1/4 inch tubing, create a fan base, and it will be extremely stiff.
Tony, we had a question regarding, do your custom units have seismic or wind load certifications?
Yes, typically what we would do on that is, I don't know that we have just a stock seismic or wind load certification, but if we had a project that had a specific requirement, what we would typically do is just hire a local professional engineer here in town who we work with on a regular basis to perform that analysis. So yes, we can have that done. I guess we could go out and do it, but I've seen different specs that call for different things. So
well, I think the main thing is that you're a custom unit, and to certify, every unit that you make is pretty much different.
Yes.
So it's very hard to certify a custom line that's every unit is different. So that's why right. You have to go down the path that you go down, where you have to hire an engineer to certify each unit. But you can do that. That's the main thing, I think, right?
Yeah, absolutely. I mean, in fact, I know we just, we're located in Kalamazoo. I mean, the Midwest is obviously our largest market, but we did have a project just within the last year that was shipped to California. Obviously, California has requirements for seismic type activity. We simply hired a PE here in town. He did an analysis of the unit, made some recommendations. We made built the unit in a specific way, and it was fine and certified for that type of environment. So just a matter of letting us know up front what the requirements are, and we will make sure that we can meet them. So yes, we can meet the wind or the seismic as required.
Sorry to take you off there.
No, that's all right. No problem. Not a problem. Moving on, just continuing to talk about fans, and obviously if there's questions, go ahead and jump in. That's fine. Everything's going to be standard mounted on open coil vibration isolators or a seismically restrained isolator, depending upon what the specification calls for. You can see in this upper left-hand picture 2 fans, belt guards with a motor trolley running overhead. That's one of the things we like to do is when we start getting into the motors, say, 30 horsepower or bigger, when you have multiple fans like this, is to put in a motor hoist rail for maintenance and working on motors, which is very effective. Of course, fans use whatever is required, whether it's a belt drive plenum fan, direct drive, whatever is required, whatever's required to make that work, make the system work. You can see on this lower left-hand picture, you actually see this as a sample of that 8-inch by 4-inch by 1/4-inch wall tubing formed into a base structure mounted on the vibration isolators. That has come into play and helped us out through the years.
And the selling point of that isolator piece, if something does go wrong with the isolator, it is easily serviceable or replaced in the field, correct?
Yes, exactly. And if you can notice in some of these pictures, you see that these things are actually bolted in place. We do know that some of our competitors are in the practice of welding these down, but we take the approach to bolt them down in case, Mike says, in case something does happen. I know it doesn't happen very often, but occasionally, you potentially could get a bad batch of isolators in from a supplier or something like that. And they're fine when they're in the plant, but once they get out, a spring breaks or something. Well, now instead of needing a hot work permit or something to use a grinder and grind that thing out and potentially have to weld it back in place, they're just bolted in place. So you can, the bolt can be removed, use a little jack to jack up the fan base, put a new one in place, bolt it back down, and the customer can be up and running in a relatively short amount of time. So that is a good point, Mike, and that's, again, one of the things through the years working with Pfizer and Upjohn is coming up with these serviceability items so that the units are easily maintained and can be serviced, maintained, and put back into service quickly if something does happen. Moving on, talking about coils and coil installations. We do not make our coils, any of our own coils, but we buy them from reputable name manufacturers such as Aerofin, Heatcraft, Marlowe. Excuse me. Those are probably the 3 main manufacturers that we buy coils from. Something here to point out, as I talked about the slope floor earlier, is if you notice in this upper picture, and you can kind of see it there, what is that kind of that weld line? Well, in these particular cases, what you're seeing is that flooring actually sloped back into the drain pan. Again, we're going to design coils, 500 feet per minute or less, but we all know that, in real humid conditions, you can still get some carryover off the coil. In this case, if you do get a little bit of carryover over the coil, it's going to fall into that sloped section, and it'll drain back into the drain pan, and again, be able to be completely drained out of the unit. Something here that's neat, it's a little hard to see, but maybe you can just see it in that slide, is that this is our intermediate drain pan, and this is actually positively sloped as well. This front trough is on a slope. It actually drains down to the coupling, and then will drain down into the main drain pan. So we like to talk about having no standing water in the units. We're very serious about that, and like I said, that goes to the intermediate drain pan as well. So 100% drainage out of slope floor sections, out of main drain pans, out of intermediate drain pans.
I think the other benefit that you see here is if you see the 3 coils the way they're stacked up and the way they install them, is if there is ever something wrong with the coils itself, right?
Yep.
You could either put and I'll let you kind of talk about that.
Yep. I guess first thing to Mike's point is just more pictures of the coils here. All the coils are individually removable. You know, even on one that's stacked 3 high, any one of those 3 can be removed without disturbing the others. And another one of the things that we do is we put coil service plugs on both sides of the coil. On each side of the unit, you'll find a removable plug that can be removed, not only on the header side, but on the return bend side as well. And that's just something we've learned through the years that you know, it's awfully nice to have those removable plugs. If you want to pull that coil, you can remove that plug and pull the coil. Sometimes people ask me why you do it on the return bend side. Well, you know, a lot of times, obviously, these coils are on the return bend side or right up against the wall with maybe only a couple inches between the wall and the return bends. If a return bend was to, you know, something was to happen, it was to freeze or rupture at that return bend, how are you going to fix it? Well, if you got a couple inches, you're not. But with that removable coil plug, you can pull that plug out, you can get to the return bend, you can braze it, do what you need to do, make the repair, put the plug back in place, and again, you're up and running with a minimal amount of effort. Again, all these features, the coil plugs, the bolted-on vibration isolators, all things that we've learned through the years to make the product easily maintained under these critical environments like pharmaceuticals and hospitals and universities. Couple other things that we think can be neat. If you see on this bottom picture, you're seeing a coil that's actually raised up above the floor, the base of the unit. And again, that's to help provide trapping space. You know, so if you get in one of those situations, maybe an indoor unit, there's no housekeeping pad, the unit's going to be set directly on the floor. You're concerned about providing trap space. How are we going to have enough space to trap it? If we're involved in the design up front and are aware of that, we can design the unit so that we physically raise the coil inside of the unit, providing the space necessary for the traps, and you're good to go, and that's no longer a concern. Again, nice picture here with 4 stacked high, or 2 stacked high coils. We do the removable slide tracks, as you can see in this picture, so that the coil is easily removed. Armor flex on the intermediate pans if desired. That is now one of our features, a standard feature as well. On the main drain pan is that main drain pan. The bottom side of that is armor flexed, just to make sure, doubly sure, there's going to be no issues with water or condensation on the underside of that pan. Just talking a little bit about this, heating coils, IFBs. One of the things that we've all seen and I'm sure lived with is, you know, mixing cold outside air and warmer return air during the heating season. We will definitely use integral face and bypass coils are fairly standard. Steam coils with face and bypass dampers configured around it. And that's, again, something up front that if we're doing a project together, we can work at and make sure a couple things. First, make sure we've sized the heating coil properly. Make sure that it's we're providing the true heating load so that we're not going to tend to overheat. If that is a concern, one of the things that we have started to do, you can see on this bypass or this integral face and bypass, is to put a bypass damper either below or above the coil, which accomplishes a couple things. Even if you're using an integral face and bypass, a steam coil in particular, maybe you can't modulate it enough and you're still getting a little overheating in the space, you can open the other bypass damper below the coil, bypassing more air, not going through the coil, leading to better control. And then also just using bypass dampers like that to throw them open when you don't need heating, reducing pressure drop through the system, saving the customer energy, and obviously cost and energy.
And you could even do the bypass around the cooling coil that we've seen on other projects where
Yep.
when they are also running in the non-cooling mode, that they're bypassing the cooling coil, so you're not taking the brake horsepower penalty for running across the cooling coil, which is, upwards of an inch in a lot of cases where you have static through a coil, which is a nice option also.
Yeah, absolutely.
As long as you have the footprint space available to do it, obviously.
Yeah, exactly. That's something obviously we would need to work ahead of, work together with up front in a project.
Yeah.
I mean, it's not something you typically do as maybe just standard, but obviously energy operating costs are a concern. That's something we can work together on and give the customer the most energy efficient unit out there. Obviously providing all types of humidifiers, direct evaporative coolers, that types of thing. This is kind of a nice chart I like to show. It's a little bit of an eye chart on here. I understand you probably can't see it real well, but this is just an example of the system static sheet. I know when I design a unit, somebody calls me up and says, hey, can you lay out a unit? I like to send back, first a CAD drawing, fan curves, coil runs, but also this static sheet, just a breakdown and an accounting of all the static in the system. That gives us a tool to look at, to go through when we're designing that project up front and make sure that all the static's going to be accounted for and that we're going to have enough air and enough pressure to make the job successful. Nobody wants to be in the situation where there's not enough air, not enough static. This is one of the tools that helps us get there and make sure we're covering what needs to be covered. So I will usually include this as a design for for you to review, to look at, and to make sure everything's covered. If we have to go back and forth a couple times over it, that's certainly one of the reasons why it's there. I'm going to just talk a little bit about this next device. This is our wheel width controller. You think, what is that crazy thing? Well, you can see in the picture with the plenum fan, or the upper right with the double width double inlet fan. This is basically a cone that we can slide over the fan wheel, and basically gives you a fan with an unlimited number of wheel widths. So we can actively change the wheel width of the fan during operation to get the most efficient, to be running at the most efficient point at all times. We know we would use this, in a couple situations, obviously, in the type of a situation where you've got a larger future CFM, but a smaller initial load. If you design with a big fan and you have a smaller future load, you need to keep your tip speed on the fan up to maintain static pressure. And sometimes that's obviously just not doable with a big fan. As you begin to slow it down, you lose your ability to create static pressure. What we can do on this is when we slow that fan down, you can move that wheel width controller, take your fan, for example, from 100% width down to 50% width, and then you are able to maintain your tip speed, maintain your static pressure, but yet reduce the CFM of the fan. And so this comes in handy at that type of situation.
And I believe you own the patent for this, right?
Yeah, we do. We have a patent on this in the U.S. And so really we're the only manufacturer that can do this type of a system.
I have a video of it too that I could probably put on after this. After you're done, I could show everybody from a video standpoint of how it works.
Okay, and the cool thing about it is, it does allow you to control the wheel width of the fan, but it's also, there's really not a lot to it. I mean, it's a pretty simple mechanism. It simply slides in and out on some rollers, and there's really not much that can go wrong, or that's going to need maintenance or anything that's going to fail. Doesn't add static pressure, any additional static pressure to the system, doesn't add any additional noise. There's really very little to no maintenance that's needed. It can be used also in a situation, like I said, with a future build-out. We've used it in that case. Again, where you've got a future larger load, you cover up part of the wheel, reduce the CFM, and then as the additional space comes online, you can move this out of the way going to full flow. So it's kind of a neat device that can be used in conjunction with a VFD as kind of a backup control, if you will. So even if something goes wrong with the VFD, you can still use the wheel width controller to maintain control of the system. Moving on, we use different types of air blenders when the situation calls for it. You'll see again one of the things you see here on that left-hand pictures. You'll see the air blenders, and you'll see the bypass dampers placed beside it. This is a situation again looking to save the customer money, reduce operating costs. During the heating season when you need that mixing, again, you're mixing the cold outside air and the warm indoor air. The mixing becomes critical. We don't want to freeze our heating coil. The blenders are very much needed, and so blender type products we use and offer. But during the cooling season, when the blending is not so necessary and not so critical, this is another situation where you can throw open those bypass dampers, reduce the load on the system, therefore reducing the amount of horsepower needed to run your fan, to save the customer money. And I guess the other, obviously the other thing, again, sizing these is to make sure we understand what the true heating load is again. These blenders obviously need velocity in order to work, in order to get maximum blending. So it's a matter of, again, understanding that true heating load during the heating season. All types of filter racks, regular big flat filter racks, V-banks, side access filter racks, everything's in the play. You can see on this slide the hinged filter rack. This is actually something that's come up with the University of Michigan. We do a lot of work for them, and they've got this crazy idea that they like to put their pre-filters and their final filters back to back without access in between them. They want to save that space, but at the same time they say they want to be able to change the final filter without messing with the pre-filter. So we kind of scratched our head for a while on that one, and we ultimately ended up coming up with this. You can see this hinge filter rack. Basically, you've got a row of filters put on a hinge, almost like a door. You're able to turn a latch, loosen that filter door up, open it up, step through, change your final filter without changing your pre-filter. Something that's maybe not practical for every customer, but certainly we think it speaks to the custom nature of the business and the creativity that we use to come up with solutions. So, if you got a tough customer, doesn't want the standard off-the-shelf solution, has something unique in mind, certainly we can step in and fill that void and come up with these unique solutions. Component selections. This is one slide that just a few bullet points, but it's pretty important. You can kind of see a couple units being built here the way we build them up. Base assembly is created first, the components go up, the casing goes up around it. The casing is never a structural part of the unit from holding up the coils or anything like that. But wheel-to-wall relationships, inlet relationships, component-to-component relationships is something that's very important and something that we are very religious about. We're going to make sure that you've got, these units are only really designed to do one thing, and that's to blow and suck air. So, we're going to make sure your fan's not being choked, going to make sure you have the proper relationships, making sure that the coil in front of the fan is placed at an adequate distance, both in width and height, that you're going to get full draw across that coil, and you're going to get the temperatures off the coil that you have asked for and that the unit has been designed for. So sometimes, we feel like this puts us in a penalty when we see designs that are maybe shorter or narrower than what we think is a good idea to do. But we think in the end it's more important to have a unit that's sized properly, that's going to provide the proper flow, doesn't add increased static pressure drops throughout the unit, and basically performs the way it's supposed to perform. Talking about field testing and stuff a little bit. We can do pretty much all manner of the factory and field testing. fan run testing to verify performance, to verify capacity, CFM static pressure, vibration testing on the fans, factory sound testing, casing leakage, panel deflection, all that type of stuff is available. We do it all in the factory. You're always welcome to come witness it at any time. We also will do similar testing in the field, bring people in to do that testing. We do have our own calibrated pressure blower that we'll use to do pressure testing. We can send a tech out, hook up the pressure blower, work with the contractor, get pressure testing, leakage testing, deflection testing done in the field. We'll send factory personnel out to do installation supervision, startup supervision, training. That last item let's talk about for a minute is on-site fabrication. Excuse me, haven't had a large opportunity to do that yet with TEC in Chicago, but certainly we believe that's one of our strong points, doing a build on-site unit using the tongue and groove panel construction that we use. It makes the unit ideal for field fabrication. We can ship in, we'll break the base sections up into small manageable pieces so they can be brought into a mechanical room. Components can be brought in. All the panels can be brought in panel by panel, the unit installed, fabricated on site. And when you're done, you have a quality unit that's has the same quality, same construction as anything that's built in the factory. So I guess keep that in mind if you run into those types of situations. Energy recovery. Obviously, energy recovery is big these days, and we certainly do build energy recovery units of all varieties, energy recovery wheels, plate-to-plate heat exchangers, just heat recovery coils, all that's on the table, all available. We can use, as far as wheel manufacturers, we can use just about anybody out there, whether it be Semco, Thermaltech, Rotor Source, Desiccant Rotors International, Energy Tech, whatever, whoever the manufacturer is, we work with all of them and buy wheels from all of them. You can see in some of these units, in these pictures, units with multiple wheels, doing units as high as 152,000 CFM with 3-4 wheels. That's definitely in play. Stuff that we can do and have done successfully. Here's an example of some units with plate-to-plate heat exchangers. We get into, obviously, being a custom manufacturer, get into irregular and different shaped units. You can see on some of these, double-deckers, triple-deckers, units with odd angles, not just rectangles, but obviously strange shapes. That type of stuff is all very doable. I think that bottom unit, the lower left, was actually something that was put into a building, and some of those lower areas had beams running across there, so the unit had to be reduced in size in those areas. That's certainly doable. Build on-site units, building units around columns, let's say in a room, been done, certainly doable. All that type of stuff where the unit has to be custom sized, custom designed. We can do all of that. I guess let's talk for a minute then about unit design. Being a custom manufacturer, we don't have a canned selection program, if you will, that we can just draw a pre-engineered unit out if you need something. But what we try to do is, if you have a project, if you have something that needs to be designed, you get it to the guys at TEC, they forward it to us. We will try to have at least the initial selections, fan run, coils, fan curves, coils, that type of stuff back to you within 24 to 48 hours. Sometimes if you just need a quick size, we may just do some selections or even do a sketch for the first revision just to get something in your hand so you can look at as far as footprint goes. And then if that looks good, we'll move on to getting the CAD drawing done. On the CAD side, we are using the 2013 version of AutoCAD. So not only will we give you a PDF, a nice picture of the drawing, but we're going to provide you with an AutoCAD file as well, so you can drop that into your CAD data to make sure the unit's going to fit in the space. It's not too tall, not too long, not too wide, that type of stuff. We can put that in. Obviously, up front on the design criteria, if you do have something particular in mind, a height limit, a width restriction, obviously send us that information up front. We can design the unit with that in mind to fit your space requirements. Again, being a custom manufacturer, we can do different types of things, sidings, any kind of a custom finish. As far as paint goes, there really is we really don't have a standard color per se. Whatever color the end customer wants is what we'll use. We can color match a piece of metal they have, or simply, like a Sherwin-Williams paint color number, and we can make that in whatever color need be. These are obviously examples of units that have had siding put on them here at the factory. We kind of joke around about this unit on the lower left being kind of the most, the fanciest air handling unit ever built, but you can see this one actually, this is a unit with a glass facade around it. Instead of the siding, they actually wanted this glass structure. This was at a hospital where you had the hospital administrator walking in, and this air handling unit was kind of setting exposed where he could see it. And he said, darn it, I'm not going to see an air handler every day when I walk into the office. So we worked with the contractor and came up with this glass facade that was put on the unit just to hide it and cover it up. So that type of stuff is in play. The upper right hand there, you'll see a multi-zone unit. Not something that not doing a ton of them these days, but something that still get a request for a couple times a year anyways, to build these hot deck, cold deck type units. And so that's something certainly that we still do to this day, and will continue to do. Exhaust energy recovery type units, build like lab exhaust units with things like with strobic fans, that type of stuff. Harrisite coated coils, Harrisite coated interiors if need be. All different types of service corridors and airlocks. 2 units with a common service corridor in between it. We can do that type of stuff. If you've got a big unit up on a rooftop, we've gotten into building almost the mechanical penthouse, if you will, the unit with a big service corridor, kind of build as one unit, mounted boilers, pumps, that type of stuff in the corridor. We can pre-mount those and send up an entire penthouse. Certainly have done that type of stuff and been successful doing that. And then just a lot of different, interesting things. Again, being custom, not every unit is quite the same. But you see here, this lower left, we like to joke around and call it the world's largest toaster oven. This is an electric heater. I forget, something like a 100,000 CFM unit, all with electric heat. So that's a little bit unique to say the least. But the story on that was this was an industrial building, and if the customer used all electric or something, they got a fantastic deal from the power company on their electric rates. So we built this giant 100,000 CFM unit with all electric heat. This middle picture shows, again, a service platform for a filter rack. You get into filter racks being maybe 5 high, let's say. That's up 10 foot, 120 inches. Getting up there to service that top row of filters becomes rather challenging. Obviously somebody would need to take a ladder in the air handling unit. Or something that we've done is to build something like this, a catwalk that somebody can go into the unit, crawl up, go up this fixed ladder, and then replace their upper bank of filters. Also have used a rolling ladder, like kind of like a library rolling ladder to get access to upper banks of filters. That type of stuff is all doable upon request. Great example here of your coil service plug. This is actually the plug removed, showing access to the coil. This one you can see down here actually being a split access, where you could actually remove the plug, one half to get the top coil and the other half to get the bottom coil. Big unit with a big bank of sound attenuators on it, double decker. All the standard components like that that you'd see in an air handler are certainly available. Bar grating with 1.5, 2 inch, whatever, turned up lip, solid welded all the way around for openings in the floor or rooftop units.
I think the main piece is that, you know, if you have a project, you want to see the quality of the airflow product, you know, you could either contact myself, Mike Smith at TEC, otherwise contact your sales rep, your sales engineer or your TM, and ask him if you could you know, come up and see him. It's basically a 2-hour trip. Take a look at it, and you can see the quality of the product. You could meet Tony and Dick, who you know, it's a family organization. You know, it's basically family organization, like kind of like TEC is. So it's a very good, some good synergies here. So.
Yep. How are we doing on time, Mike?
I think we're about done here. I think we're about done here. So.
Okay.
Any other things? And then if anybody has any questions or anybody wants to discuss anything, give me a ring. Again, I think everybody has my email address from the presentation, but it's mike.smid, S-M-I-D, at tecmungo.com. Otherwise, my cell is 847-630-7867 to give me a call if you need anything. But again, just wanted to introduce everybody to the product. We've had a relationship for a year with them. We've had a lot of success. In fact, actually one project we did, the mechanical contractor who installed it, he actually just he basically stated to us, he said this is the best quality custom unit he's seen in the marketplace. So it's always nice to see from a new partnership like that we have here. So please contact us, and we'll be happy to help, and we'll go from there. Thank you, everybody, for attending.
Great. Thank you.
Thanks, Tony.